All right, it is 3 o'clock, and this is a fairly quick program, so we're going to go ahead and get started. My name is Sarah Rosenkrantz, and I'm the Exhibits and Education Assistant here at IU Museum of Archaeology and Anthropology. And welcome to our Coffee and Curator event, Cold Sourced and Cold Brew. If this is your first Coffee and Curator event with us, we do these once a month. It's going to be a short 10-minute talk followed by 10 minutes of Q&A. And you can ask Ryan any questions you want. You can put them in the chat and I'll read them off. Or if you want to come unmuted and ask him yourself, that is fine too. Before we get started though, I would like to acknowledge that IUMAA and IU Bloomington is on the traditional homelands of the Miami, Shawnee, Potawatomi, and Delaware people. And their culture is still very influential in the region. So if you're in the area, I encourage you to research them a little bit. And if you're not, I encourage you to research the indigenous people in your region. And with that, I would like to introduce our speaker today. Ryan Edward Peterson is a PhD candidate at IU's Department of Anthropology and a research fellow at IUMAA. His research focuses on the study of native copper production and value in the northern Lake Superior Basin during the Nipissing high paleo-lake level event, which was 4,000 to 6,000 years ago. His research interests include recreating native copper working techniques, as well as understanding how the technological organization of metallurgical production systems express the value that the native peoples placed on those materials. Additionally, Ryan's research interests led him to study the development and spread of pre-modern industries and the effect these industries had on the people who adopted and developed them. He has conducted fieldwork on various islands and coastlines throughout the Great Lakes, including Beaver Island, Isle Royale, and the north and south shores of Lake Superior. And his current work is focusing on sourcing native copper in the Lake Superior Basin using lead isotope analysis. So, welcome, Ryan.
Well, thank you very much, Sarah, for that introduction. And also a thank you to the team that puts on these Coffee and Curators. This is a collaborative event, and they do a really good job of that. Today, I wanted to talk a little bit about copper sourcing itself. As an archaeologist who works with native copper, I have the issue of copper sourcing come up a lot, and I get a lot of questions on it about how it's done, about what it actually means to source an artifact or to source copper. So what I want to do in the brief time that we have is to give a short little introduction to what it actually means to source copper, to talk about two of the primary methods that archaeologists use in sourcing native copper here in North America, and then kind of end with a brief description of the sourcing project that I'm currently working on right now, actually. So starting off, when it comes to sourcing copper, what the basic principle of this is you are taking an artifact, in our case, native copper, and you're trying to match this artifact to a source. And this source is really where the copper appears in the ground. It is its geologic source. So in the case of copper, this is going to be a copper mine. And the goal of this is you need to get a signature from the copper. Now, I'll talk about what I mean by signature in a couple slides, but what the signature really is, it's kind of a chemical makeup of the copper itself. And you use this chemical makeup, this signature, to match the copper artifact to a copper source. So in order to do this, the first thing you need to do is to actually have something to compare your copper artifact to. This is done by actually going to known copper sources and then collecting samples of copper from those sources. This can be a really large collection. This can be on the smaller side, depending on how accurate you want to be. You are then going to take each sample you took from your sources. It's usually best practice to take 3 to 5 samples from each source you're looking at, and you're going to characterize these samples. Essentially, you're going to get a signature for each copper sample that you get from the geologic source, and you're going to have kind of a summary of what a signature would be from that source, and that's your characterization. Now, the reason this works is because of a couple, there's 4 different principles that I have listed here, but the reason it works is because we have variation between different sources of copper. And what this variation is determined by what signature you're looking at in the copper. And they're really determined by a couple different things, including the origins of the metals, the origins of the different fluids that actually made up the formation when it formed however many years ago that was, the age of the deposits, and the time span the ore has actually been in a given mining district. And taken all together, what this gives us is variation between different mining locations, and it allows us then to match our copper artifact to our copper source. Of course, this isn't without problems. 2 of the primary things that archaeologists need to be careful of when we're going through and sourcing copper is first, the amount of overlap between our different geochemical signatures in deposits. What we often see is if we take copper from different places and we get that signature, there can be overlap from 2 sources that are nowhere near each other. This is a common problem actually when looking at copper sources in the Mediterranean. There's a lot of overlap between these sources and sources other places, and it makes sourcing very difficult. The other kind of problem, if you will, that often comes up is that as an archaeologist, we're never going to be able to source all of the potential copper sources that could have been used. This can be partly due to funding. We can only run so many samples, but it's primarily due to the fact that we'll just never know what all the sources were. We're never going to find them all, and it's possible that some of them have been completely depleted thousands of years before, and there's nothing left for us to sample. That being said, these are not reasons why it's impossible. They're just things to consider as archaeologists as we go through and sample the copper. Now, I mentioned the term signature, right? Comparing the signature of the artifact to the actual source. When it comes to sourcing copper, there's 2 primary types of signatures that we can look at. Here in North America, when it comes to sourcing native copper, the primary one that's been used is an elemental analysis. The native copper we have here in North America is upwards of 99.9% pure elemental copper. And what this means is that there's about a 1% in there that's not copper and is made up of other elements. This could be silver, this could be iron, this could be a variety of other elements that all occur in different amounts. And those amounts vary depending upon the copper mine. And what we can do is we can measure these amounts and actually group the copper mines based off of the different levels of elements that they have within them. This is also called trace element analysis. There's really 3 primary instruments that get used in this. The first one and kind of basic workhorse of this is an inductively coupled plasma mass spectrometer. This you would take, for example, a drill, you'd get some really nice copper shavings, and you would run it through the machine and it would give you a readout of the elemental analysis. A step up from this is a laser ablation, ICP-MS. And this uses a little laser to take a surface reading of the copper. It's minimally invasive, which is really nice for sourcing artifacts, but it's really limited to a surface analysis. The last one, which is probably my favorite of all of these, but isn't as widely used, but could become so in the near future due to advances in its accuracy and technology, is X-ray fluorescence. This is a purely surface sample that does not require any destruction of the artifact, but the actual uses of this one haven't quite fully been tested. To give you an idea of what the sampling looks like, I'm not going to get into the statistics, but this is a chart taken from Hill 2009, and it shows you what it looks like with all of our different samples. So we have Snake River down in the dark blue, and then we have Champion up in the light blue. And if we were to have an artifact from Champion, and we were to sample it using trace element, it would most likely group up in this circle where you see Champion in light blue. The other method that can be used, and this is the method that I'm currently focusing on using, is lead isotope analysis. The machine used for this is similar to the one we just saw, except this is a multi-collector ICP-MS. What a multi-collector does, instead of analyzing the different amounts of multiple elements, this gives us the different amounts of isotopes within a single element. And an isotope is simply a different particle of that element that has a different atomic weight to it. Now, when it comes to lead, there are 4 different isotopes of note. 3 of them are what are called radiographic. This means they occur due to radioactive decay. The 4th one, which is lead 204, is not radiographic and actually remains constant. When different ore bodies are formed, they have different amounts of lead in them, and dependent upon their age, there's going to be a different breakdown of those elements over time. What this essentially means is that we're going to have different levels or different amounts of different isotopes in different copper deposits. And by comparing these different amounts of the different isotopes of lead, which occurs in very small amounts in the copper, we can actually source that copper itself. Now, to give you an example of what that looks like, this is a chart used by Corey Cooper to 2021. Now, when Dr. Cooper did his analysis, he compared primarily sources from the Arctic, in which we see a grouping here in blue, and there's some overlap between the different sources that you see with the Yukon versus Alaska versus copper mine. What's important for my study on this is you see the little black dots up kind of away from the rest, one up here, if you can see my mouse, and one over here. These are sources from Michigan, which is demonstrating variation in the sources from Michigan. So this has led to my study trying to look at the lead isotopes of different geologic copper formations in Michigan. So this is a map of all of the sites I've currently sampled, with a couple more samples from up along Lake Superior's north shore on the way to me, as well as a couple more from Isle Royale. And my analysis is going to be looking for variation within these samples. And if that variation holds to be true, and that these samples are able to be, or these mines are able to be distinguished from one another, this can then be applied to an archaeological context, in which this can then become a comparative source that we can use to then sample artifacts. For example, there are copper artifacts at Angel Mounds. I work in the northern Lake Superior Basin on copper production sites, and we can then use these to sample and source our copper artifacts. So that is the end of my 10 minutes for talking, and I'll turn it over to Sarah to field any questions we now have. And I'll also quit sharing my screen.
Thank you, Ryan. That was great, and I understood it, which was exciting. Science is not always my strong suit. I was wondering, you mentioned that sometimes there's overlap in like the sources. Is there any way to figure out, like, to separate it past that, or are you kind of just stuck?
That is actually a great question. Oftentimes people are just stuck, and this is part of the reason I'm looking at using lead isotope analysis. We've come a long way with elemental analysis, and we're to a point where we can distinguish between populations. So we can say it's coming from the Great Lakes versus the Appalachians, but it kind of gets muddy when you start to look at some of the sources and there's some overlap. The hope, at least with the lead isotope analysis, is that we can get a little bit more crisper lines, as you could say, between some of the mines. But essentially the only way to get around it is either hopefully the technology improves or to come up with a different method.
Cool. Yeah, waiting for technology is always helpful, if it could only be now and in the future. Yeah. And like I said at the beginning, if y'all have any questions, post them in the chat and I will ask Ryan. So I also had another question about what interested you in this topic, and how did you kind of get started on it?
Another great question. So I grew up in Michigan's Upper Peninsula, and I always had an interest in kind of the local history there. And I went to Northern Michigan University to study archaeology, and I was going to work anywhere else but the Great Lakes. But I had actually gotten an internship on Isle Royal, which is now my current field site. And I just really fell in love with Isle Royal, fell in love with the metallurgy going on there and the culture. And then for sourcing itself, I actually had zero plans of doing any kind of copper sourcing when I started at IU. I had told my advisor in my first meeting that I wanted nothing to do with that. And I stayed that way for about 2 years. And then I developed my research project, and I thought, I really need a way to connect my different sites I'm looking at. Then I thought I could probably use sourcing, but I don't really want to. And then the more I looked into it, the more I developed my research project, the more I kind of came to a grudging conclusion that I needed to do this. And I've slowly flipped over to kind of I'm really gung-ho about it now. And I actually spent my summer collecting samples for my lead isotope analysis.
That's awesome. Matthew had a question. Have you considered using a multi-isotope approach for determining sourcing, both Cu and Pb isotopes?
So that's actually a great question. Unfortunately, in the Great Lakes, well, not unfortunately, we have the information now, but copper isotopes don't work for sourcing, at least in the studies that I've read for the Great Lakes. Bornhurst did a pretty detailed study of the copper isotopes, and they don't allow us to do any sourcing in the Great Lakes. So unfortunately, that isn't a viable option, at least in that area.
Awesome. Good to know. Ronald was curious about what types of artifacts would contain copper.
So I may not fully understand your question. Where I work, the artifacts are made of native copper, and they're pure native copper artifacts that are pretty easy to identify.
I think he what types of artifacts? Like, is it mostly jewelry? Is it
Okay.
pots?
No, that makes a lot more sense than what I was thinking. Yeah, so we have a variety of different types. Primarily, especially in the period that I work in the mid-Holocene, we see a lot of tools being made of copper. So we see things such as large gaff hooks for fishing. We see things such as copper knives. This isn't an artifact. I made that one. But later on, we definitely see a lot of ornamentation. We see pendants. Actually, in my first slide, there was a pendant there, a bead, and then actually an ear pin. So a wide variety of things are being made of copper.
Cool. Melody asked, is there a regional data set for copper sourcing that you will be building or contributing to?
So for elemental analysis, there is. George Rapp, and then this was continued on by Mark Hill, have been working at putting together for elemental analysis. Mark Hill actually makes all of his data available on his website open sourced, which is really great for anybody adding on to that. For lead isotope analysis, there's actually only been one study done here in North America, which is another primary driver of my research. And this was done, I actually already mentioned him, by Corey Cooper up in the Arctic. So I, in theory, could match my findings up with his if I wanted to compare the Arctic versus the Great Lakes. But I would say regionally, I would be building, I guess, from scratch, the lead isotope analysis database for comparison.
They said thank you for answering your questions, their questions. Are there any more before we sign off? We're running up to our time. I don't think so. I think that is it. And you did a fantastic job, Ryan. Like, there are lots of comments saying great job, just to let you know. So thank you so much for this wonderful presentation. For everyone else, our next Coffee and Curator talk will be on September 22nd, about a month from now, and it's going to be about curating the Angel Mounds Legacy collection that Melanie has been working on. So hope you guys can join us, and thank you.
Thank you, everybody.